Morning and happy Monday or Tuesday as you're watching this. This is part 2 of Notes 2.4. Now we're going to talk about several postulates and theorems as they relate to parallel lines crossed by a transversal. All right. These all go back to the stuff we talked about last time about what you see is what you get, where angles are congruent, where angles are supplementary. So I hope you watched that and digested all of that, or we're here in class to digest it all. Now we're going to talk about exactly the theoretical geometry behind it. So first up is the corresponding angles postulate, which tell us that if two parallel lines are cut by a transversal, then corresponding angles are congruent. So a conclusion that I can make, if I'm given that in all of these cases, M is parallel to N, in all of these cases, M is parallel to N, then I know that, for instance, angle 2 is going to be congruent to angle 6. That's my conclusion, because 2 and 6 are corresponding angles. Therefore, 2 and 6 must be congruent. The alternate interior angles theorem tells us that alternate interior angles are congruent. So if that's the case, I know M is parallel to N. I can look at this and say, okay, you know what? Angle 3 is going to be congruent to angle 5, because those are alternate interior angles. Alternate exterior angles, and this is how these are the reasons why we when we do proofs, as you'll see in a moment. Alternate exterior angles are also congruent, so that would tell me that, for instance, angle 1 is congruent to angle 7. Consecutive or same side interior angles are supplementary. If that means they're supplementary, then I can conclude angle 4 and angle 5 are supplementary. All right. And then exterior angles are also supplementary, congruent, congruent, congruent. Exterior angles are also supplementary, so that would tell me that angle 2 and angle 7 are supplementary. So those are all the stuff we talked about last time. Corresponding alternate interior, alternate exterior. Those are all congruent. Same side interior, same side exterior are also are supplementary. And some other reasons and examples of things that we might get as we go through proofs. If I have the definition of congruence, that means that, say, if angle 2 is congruent to angle 6, then because I know the definition of congruence means things that are congruent means everything is congruent, then I could say measure of angle 2 is equal to measure of angle 6. That's an example of how I would apply the definition of congruence. Definition of a linear pair would say if angle 1 and angle 2 are a linear pair, then we know that linear pairs are supplementary, so angle 1 and angle 2 are supplementary. Not enough room to write in that box. That's the definition of linear pair. If I can prove that 1 and 2 are a linear pair, then angle 1 and 2 are supplementary. And then the definition of supplementary is if angle 1 and angle 2 are supplementary, then I know that measure of angle 1 plus measure of angle 2 is equal to 180. Don't use the degree symbol. So that's the definition of supplementary. So again, just a kind of structured way of thinking that we use in proofs. I hope this all makes sense for you. Let's look at the next page. Now we're gonna go backwards. All right. So now we're gonna do the converse statement. Remember we have if P then Q is our conditional. Our converse is if Q then P. So on the last page, we said, hey, you know what? If parallel lines are cut by a transversal, then corresponding angles are congruent for our corresponding angles postulate. On this page, we're going to say if angle 2 is congruent to angle 6, then angle 2 and angle 6 are corresponding angles, then I can conclude that my conclusion is that M is parallel to N. All right. So alternate interior angles. If I tell you that angle 3 is congruent to angle 5, then I know that M is parallel to N because I've shown that alternate interior angles are congruent. If alternate exterior angles, so if this is angle 2 is congruent to angle 6, then I know that M is parallel to N. All right. It's the same words that we would use, the same definition of each of these. You know, if alternate exterior angles are congruent, then lines are parallel, etc. Same side interior. So this is angle 4 and angle 5 are supplementary. That tells you that M is parallel to N. That's my conclusion. My same side exterior angles, so angle 1 and angle 1 and angle 8 are supplementary. That tells me that M is parallel to N. All right. What this big picture technical geometry terms, that means this conditional statement is P then Q. If two parallel lines are cut by transversal, then pairs of corresponding angles are congruent. If I looked at the converse of it, then I would say if the pair of corresponding angles are congruent, then the two lines cut by transversal are parallel. That's the converse, okay? So each of these, if I'm proving the lines are parallel, then that's the converse of corresponding angles postulate, technically speaking. And then if I'm saying that if I say that the lines are parallel, then I can conclude that the corresponding angles are congruent. That's the conditional statement. I know that didn't make sense. The point of all this is when corresponding angles are congruent, lines are parallel. When lines are parallel, corresponding angles are congruent. I'm never going to get hung up if you say it's the corresponding angles postulate or the converse of the corresponding angles postulate, because all of these postulates and theorems are biconditional, which means you can do if P then Q or if Q then P, and it works both ways. All right. Some examples. Again, substitution. If I tell you that angle 1 is congruent to angle 5 and angle 5 is congruent to angle 7, then by substitution, I could say that angle 1 is congruent to angle 7. Okay, that's substitution. I substituted in 7 for 5. 1 is congruent to 5. The transitive property is very, very similar. So if I say that measure of angle 2, no, that's not good. If I say that angle 2 is congruent to angle 4, and then the transitive property tells me that angle 4 is congruent to angle 2. No, that's commutative. Gosh dang it. Forget I wrote that, rewind the video, delete that, and then we say if angle 2 is congruent to angle 4 and angle 4 is congruent to angle 8, then angle 2 is congruent to angle 8. So substitution and transitive are very, very similar. A lot of times you can use them interchangingly. Transitive means that if A equals B and B equals C, therefore A equals C. Substitution would say if A equals B and B equals C, then A equals C. I mean, they're very, very similar. I wouldn't get hung up on how those work. All right. So that's your notes on a little intro to proofs and statements and conditionals. I know it's tough logic. We'll talk more about exactly how these proofs work next time. The important thing to get down here is kind of knowing that the principle of if I have which angle relationship, then that shows that lines are parallel, and the opposite, the converse. If lines are parallel, then that will show me that angle relationship. All right,